All right, everyone, good morning. Wow. Voice from above. We need that because coming out of Wade's energy, there was an energy drop in this room. We need to change that, and I guess screaming loudly and talking most animatedly will do that. Thank you all for joining. Adaptive reuse, it's a super sexy topic, I know, perhaps the best one of the entire conference. Everyone wants to hear about how we're gonna reuse buildings, right? I gotta say, I owe Wade a beer or two for setting me up. He talked adaptive reuse. You see those awesome pictures of malls and Sears buildings and former headquarters, and that's exactly what we're talking about today. Specifically adaptive reuse as a tactic, one, to get to revenue faster, which we all like to do, right? And two, to be sustainable. We rarely talk about the circularity of adaptive reuse. It's the original recycling, right? So I'll kind of lay out the overall thesis and then step away and let my panel of esteemed experts talk from their unique perspective about how they're doing this, the challenges of doing this in the future, particularly vis-a-vis AI. Gotta say AI, right? It's within the first 5 minutes of a panel for sure. So the overall thesis here is that the internet was actually built on adaptive reuse, starting with the Maze and the NAPS, the telecom carrier hotels. Think about 350 Cermak in Chicago, 111 8th in New York, 1 Wilshire, Infomart, to name a few. These are all adaptive reuse buildings that were tied to the telecom infrastructure and became the first data centers, storied buildings that still to this day carry lots of critical load. And so we did this to build the internet and some of the first data centers, and then went through a period of about 15 years of a lot of greenfield. We knocked a lot of buildings down. We took over a lot of dirt when power was plentiful. Remember that back in the day? And built a lot of greenfield, myself included. I'm sure you all are involved with these projects. But we get to where we are today, and there's a very interesting and alarming market context. We've got declining vacancy. The JLL end of year 2024 data center report says we ended up at a 2.6% vacancy in the US colo space. It's as low as it's ever been, and that line is actually still bending downward. We might get to zero colo vacancy. We've seen over the last 5 years a blended CAGR on rents of 11%. In smaller chunks, it's even higher, as high as 28%. So availability is going down, rents are going up, and we're seeing immense competition for colo space. And you know this if you're a customer. You're competing with the Mag 7 folks who have endless budget. We've also got a lot of visibility around the data center space and the board now, as it's a board level agenda item, and there's a lot of visibility around spend and return on investment. And don't forget about sustainability. That didn't go away. That's what we talked about for a couple of years at conferences, and then AI came along, and now we're talking about AI, but sustainability is still an important part of what we do and what our boards expect from us. So we've got these constrained market conditions, we've got sustainability pressures, and now on top of that, we've got the looming specter of AI and how it's completely changed our basis of design. So we have a hard time finding space. There's a lot of competition. Rents are going up. We've got a new way to deploy a whole different type of technology, and we've got sustainability. And what that begs is, are we going to maybe start looking at adaptive reuse again if we can't find space and deploy quickly, need to get to revenue faster, and be sustainable all at the same time. So that's our thesis, and these gentlemen here are going to walk us through this. I'm going to pause real quick and let them do an introduction real quick, name, title, what you do, and then we'll get right into the questions.
Sean Novak, Tech Fusion, CRO, in charge of bringing revenue to the table.
Greg Metcalf, Senior Director for Equinix, part of our global design function.
I'm Bill Mazzetti. I'm a Senior Vice President at Rosen Electric. I actually work at the intersection of data center and energy.
All right, first question to Sean. Tech Fusions. Tell us a little about what you're doing there, because your basis of design is exclusively adaptive reuse. Tell us about the why, the supply chain, the demand, the tech, and the sustainability as well.
Well, exclusive is a little aggressive. I like to start off with adaptive reuse. So we've been doing this for years, right? I mean, there's old semiconductor buildings that have turned into data centers. They might have had 5 megawatts worth of power. That was massive. They grew to 10 megawatts. A lot of our sites that we're using as adaptive reuse are starting off as a 10, 20 megawatt utility substation that sits there that I can actually power on. This is very important on the sustainability side. Embodied emissions, 80% of embodied emissions are made up of concrete. So if I already have 600,000 square feet of adaptive reuse buildings, I already have some utility power available. The next big step for us is where is the other power coming from? Because it's not coming from the grid. We're just simply out of power. So in Tech Fusions, we're focusing on the nat gas turbines. Our sites are, one of our largest sites is our Keystone campus in New Kensington, Pennsylvania, that has over 1,400 acres with 3 gigawatts of nat gas power availability. This is probably, some of you might have seen the announcements on this. Wade mentioned, even Dave right before Wade at the keynote, about PA being one of the sought after markets. Well, because we have a lot of facility space out there, we have a lot of acreage, we can turn around power extremely fast. So you talk about supply chain. Our clients don't want to wait 3 years for greenfield builds. They don't have time to wait 3 years for a greenfield build. If you think about an 8,000 cluster for a NeoCloud, that costs them about $250 million worth of GPUs that they have to purchase. For every month that they don't have those GPUs running and operational, that's about $25 million a month that they're losing. So their ROI is about 10 months for these NeoClouds.
All right, Sean, to give the crowd a new, cool, high-tech AI moniker, can you tell us what NeoCloud is?
I don't know.
That's a good buzzy term.
I just heard it, so.
Okay. But NeoClouds, they're the next thing?
Yeah, NeoCloud's the next thing. If you ever talk to one of these AI companies, they're just like, yeah, we're not an AI company, we're a NeoCloud. I was like, okay, sorry, NeoClouds.
You heard it here first. Sean Novak, Tech Fusions.
So your CoreWeaves, your Lambdas, your Vultrs, they're basically a GPU as a service, or they're providing GPUs in a big AI warehouse. We heard that a lot this morning too, right? So going back to like every time that they want to wait 6 months to go build a 15 megawatt, 8,000 GPU cluster out, that's 6 months of lost revenue that they have. So all of these different NeoClouds are saying that I need power and I need it yesterday. Where are you going to put it? Well, if I'm doing greenfield, it's going to take me 18 months, 36 months to provide them that type of capacity. Adaptive reuse, I have it tomorrow. We can do the fit outs extremely fast. Even if we're running temp gear just to get them operational, they don't care about that because they want to see that revenue hit their books as soon as possible.
Excellent. Thank you, Sean. Turning next to Greg, as we all know, the Equinix portfolio is huge. It's varied. It's new. It's old. All kinds of different properties and buildings. Give us some of the maybe why nots. We heard from Sean some of the whys, some of the challenges around doing adaptive reuse, particularly at scale, because that's what Equinix does. Share some of your thoughts.
Thanks. So we've got a huge portfolio of new buildings, old buildings, some that are up for redevelopment at the moment. One public project that we've got is redevelopment of our DC2 facility in Ashburn. It's kind of the center of the internet in Ashburn. It's a really old building, but the challenges are they're live with customers inside them, live fiber coming in and out, very central to the functioning of world transactions. So we have to very carefully, with a fine-tooth comb, deal with replacing the equipment piece by piece in that building. It's open heart surgery with customers in the building. So those kinds of projects have to happen to keep those buildings running because people are not going to move out of those buildings. They're the very core. You mentioned the Infomart. The Infomart's a huge building in Dallas. It's the center of the internet in the Southwest United States. Miami, Napa, the Americas. These are huge buildings that over time take some care to look after.
So it's the complexities of just live load and uptime, all the bread and butter stuff for the data center industry, huh?
And then you talked about some new builds as well. So a lot of new build stuff going on at the moment. The challenges with reuse for new build stuff is it's difficult from a cost perspective to make some rebuild stuff work for us. And some of the buildings struggle to fit in the kind of equipment that customers want to use, either because of slab loadings or floor-to-floor height or just the length of time that it would take some of the projects. So somewhat conversely to some of what Sean said, some of the projects that I've looked at take longer to get done than a greenfield project does because the building needs more work to it to get it there. If you can find a great one, and I think that's what Sean's alluding to, that's ready to go and makes your life easy to reuse quickly, great. Unfortunately, we don't seem to have many of those.
I know of a few. If anyone's looking for an industrial asset to reuse, call the JLL guy. That's a good transition into to Bill and what he does, because at Rosendin you have built and powered some of the largest data centers in the world. Give us your perspective on this challenge, the whys and the whys nots, as we move into AI density, what you're seeing, what you're doing, and again, it was nice to hear from Wade talking about retrofitting, what JLL calls future fitting. That's a really good buzzy marketing term. Future fitting, converting existing colos to AI densities, and his idea of keeping the perimeter and densifying the racks. What are you seeing? What are you doing, Bill? What's kind of the state of the art from a large scale electrical perspective?
Well, I think it's a bit of a bifurcated argument. So we've been fortunate enough to be embedded in some of the largest AI bespoke programs that exist. You've heard certainly about in the media and for the president about the project in West Texas. That's our project, and several others that are going on right now. And so there's really kind of two pieces where I think that you look at AI as a business, especially AI as a service outside of the core view, but really the end users now, which would include OpenAI and some new hyperscalers that have arrived in the market. They are establishing a relatively strong and rapid foothold for just megawatts in footprint. We have a saying, megawatts are megawatts. When you look at an AI facility, it doesn't really vary significantly from a cloud facility. I mean, the output of what works and changes is downstream of the UPS. Mechanically, it's a very different building. We heard from Wade today, which we'd heard whispers from NVIDIA for months that they're going to raise the inlet temperature. That changes, that relieves some of the problems we've had with facility development. But I think that you've got two pieces, one of which is what Greg alludes to, which is the adaptive reuse of existing facilities while operating, which is where I started in the business, and he's absolutely right. It's open heart surgery, it's high risk work, it takes forever, but it's necessary because that asset, more importantly, is in a good location. It has substantial fiber, which is pretty critical. And to be blunt, from a real estate standpoint, it's fully depreciated, the returns on it are better, and the rents are pretty good. And then there's the other side of it, which is the disused facilities that are on the market. And that, I think, again, those are usually lit buildings, not in the 420, let's go get stoned kind of point, but they are lit by fiber. And but as we've alluded to, is they're probably short on power, and there's ways to get around that from a non-utility solution, of which there's a host of options. But that's a relatively tactical and transactional piece. So I think what you heard today, which is something we've subscribed to, cloud and AI don't work the same from a computer science basis. They are fundamentally, you've got the availability in cloud and the availability of AI. Those workloads are different. You can clock down AI. One thing we're seeing on a utility basis now, AI works, and you heard it from Wade this morning, it's a 5 megawatt block maximum. As they continue to get bigger, they're going to cap it at 5 because fundamentally that disrupts all the upstream systems electrically. And so they've kind of stuck with that. And so they'll get more processing out of that. But that form factor, which went from 1,250 kW to 2,500 to 5, they're going to keep it at that. So that works for all of us. But now you talk about 5 megawatts of compute or 2.5 megawatts of compute that fits in a container. And so the question then becomes, Tony Grayson's missing today, but you talk about, well, if I need to do a top-up on that, do I just put that capacity both for compute and infrastructure in the parking lot into a relatively strong container, and it's connected into the building, and off you go. So I think what happens is that we're in a really, not formative time, but I call it squishy, is programmatically solving
Switchy? Is that the technical term?
Squishy.
Squishy,
Which means it's really, that kind of flies in the face of real estate engineering, procurement, where everything's kind of a regimented formula. And that's not what we have today. You have to solve power availability. You have to solve, can I fit it in the building? For example, people forget an AI rack weighs 10,000 pounds. It's a 600 pound per square foot live load on the floor. And as Kurt Lindorfer will tell you, that does not exist in an existing facility. You have to put them on the ground floor. There's ripples all over the place, but not insurmountable. And so, I'm going to leave it there for right now. But I think, let me close with one thing. Power is one of the last more confusing miles we're dealing with right now. Clearly you hear about the shortage. That's come from the utilities for 50 years in this country because we've been good citizens. We're losing less power per capita, less power per compute transaction. We've done that for 40 years. And in the last 4 years, power went the other way, and that comes from three factors, not just data centers, but it's fleet electrification, electric vehicles, electric trucks, all that, as well as the building codes moving to more electric. We see that in California, Wisconsin. But by 2030, natural gas for heating and cooking will basically be outlawed in the United States. I don't care what your politics are, that's where the codes are going. That's going to drive more grid demand, which drives other solutions that you've got to deal with. The last thing on power, and I've seen this 3 times in the last month in 2 different jurisdictions, an interconnection application be how much is the load, what's the demand, when's it going to come online? The other half of that application, since we have on-site power, the utility says, can you dispatch it? Can you load curtail? Can you actually act like an interactive load to the grid, which we've talked about for over a decade? Now, the great part is what most people don't know about NVIDIA. There's demand load management, which is an ability to declock that plant relatively quickly. Now, if you tell the utility I'm going to go from 100 megawatts to 20 in 2 seconds, they're going to be a little upset. But the fact is now that those loads are becoming more interactive with the utility. That helps solve part of the problem, but you still have to hit it with a bigger hammer for megawatts.
Greg, did you have a comment?
I was intrigued by Bill's comment at the end about some of the utility challenges, and I wholly agree. I think we're going to see utilities bring demands to large load consumers where they say you must be a flexible user.
Yep.
You can't get a firm contract like you used to be able to, and you will end up with a non-firm or interruptible contract or a load reduction contract like other industrial users have done before. And we're planning for that world as it evolves.
What are your thoughts? Question to the panel. Thoughts on, does this new power world that we're in, constrained and perhaps smaller deployment unit size due to this kind of bifurcation of use case, cloud versus AI versus enterprise, does adaptive reuse help this, hinder this? Any influence that you see looking out over the next few years for the ability for these buildings that are already entitled, landed, sometimes powered to provide load with a different profile?
Was that one question or 7?
That's at least 6.
So I'll just start and say that we've got development for our xScale business, building for our hyperscale partners. They tend to be the very large facilities that are more remote, but we also have our retail business that's the bread and butter of what Equinix has been for 27 years, more in metro areas like in Ashburn here close to DC. And they host the nexus of interconnection for the world, all around the world, but especially here in Ashburn. Those retail buildings, we think the future of those is that as AI grows, that inference model is going to need to live somewhere. We think that it needs to live at what we would call the edge, meaning in the middle of our retail interconnection buildings, sitting on that nexus of interconnection, because that inference AI is going to need multiple data streams. It's going to need multiple ways in and out of the building. It's going to need to connect to multiple services. It really is an interconnection model, we believe. So that's one answer to your question.
And I'll say that like you have a lot of the adaptive reuse. If it's a facility that has 200,000 square feet, that's just a start. but it has to have ample amount of land and additional power, whether that's through PPAs, solar, wind, whatever you want to have, or the nat gas turbines like what we're doing, or even if the utility can do an upgrade down the road. The fact of the matter is we're not just doing adaptive reuse. That's the beginning to the end. So everything else will be greenfield after that. The other thing that we really have to consider is like that this technology is changing every 6 months. I don't know if anyone was at GTC a couple weeks ago or listened to the keynote, or if you were at GTC the previous year. They've gone from A100 to H100 to H200 to B200 to B300 to Rubin. This is all happening within a year. So that technology has gone from 17 kW a cabinet to 120 kW cabinet to 400.
It's kind of
kW
silly,
cabinet.
isn't it?
It's like what the hell?
Like
are we
change is
doing?
good, but can AI just stop for a little bit? I mean, come on.
I have a theory behind that, though.
Oh, pray tell, Bill. A theory.
The theory with that is that, so if you get into computer sciences, not every workload. So there's two things, one of which is our GPU is going to replace CPUs, and CPUs are actually a kind of an accelerator in a GPU server in many cases. But not every AI load needs Rubin or Blackwell or H200. I mean, it's going to, I think what you have here is a scope of processor technology that will get mapped against the workload that's there. Now, the one thing we're changing, so I'm an old fart, so which is pretty obvious, but I've been around in the mainframe DASD days where it's a hardware-centric environment. That's exactly what AI is. Cloud is a software application-centric environment where everything's kind of commoditized. You can feed it the same way for power. It's air-cooled. There's tactics how it varies, but the fact is that those, when you talk about Cube and everything else, that's an ecosystem like a mainframe was. But not every workload will have to have the cabinet that cost you $2 million to do. And so I think that hasn't sorted itself out yet, merely for the fact the application layer and the businesses behind it haven't sorted themselves out. Now, we've all been in this business a long time, and you watch the rate of change, and the rate of change right now, as we alluded to, is relatively staggering. But I believe there's a little method to the madness. It's not they're going to abandon the older processors. What happens, it's like the 8088 from Intel, that goes into something that's just slower. You just don't need to hit it with that big a hammer.
Processor adaptive reuse.
Exactamundo.
Whoa,
So
that's a panel for you,
Yeah,
right
so that's
there.
the next one, right? So you hit it spot on. So like when you're a NeoCloud and you're buying the GPUs, you're charging $4 an hour. Mm-hmm. That $4 an hour only lasts for a year, and then there's a new technology. So that H100, for example, becomes 2 years old. Now you're charging $299 an hour.
Exactly.
So it's a tough business, and you're only signing up a 2-year contract, but yet you want to come to someone like us and say, I want colo from your data center. I'm going to do a 5-year contract. I need 200 megawatts. I need it built in 3 months. Who's financing this? I can't.
So, which, by the way, the capital markets have an appetite for this. So if you pull back a PPA, we're in the energy business and we're in the microgrid business, like a couple of us up here. The returns are staggeringly good. So the capital markets are pretty smart. They kind of latch onto that quickly. So I don't think there's an issue of capital coming into the energy space, because if we don't take it in as the load, the grid will take it. So the good, that's actually the better part of the operation. You'll hear if you go to I go to the finance conferences because I like to know where the money is, because then it means we can work. And their real concern is really not the PPA, but it's the lease termination terms, which are shorter than the financing package. But nobody's worrying about it right now, because I mentioned to a lot of people, has anybody ever tried to move a data center? It's really freaking hard. You basically never move them. They get to a point where they're adaptively reused, they're kind of decanted. So you don't move them so you don't lose the financing package or the lease, but it is, they do get kind of defanged or kind of slowed down a little bit.
So switching gears, let's talk about the enterprise a little bit here, because they're kind of in a tough space. What do you think they're going to do in the face of needing AI, not having up-to-date infrastructure that can support AI, but knowing with inferencing coming and monetization of AI, they have to do this for test dev, product development. Mm-hmm. They do happen to have a whole bunch of space and power that they've stranded over the years, moving everything to the cloud. do you see the enterprise deploying, vis-a-vis future fitting or retrofitting, deploying AI on site, doing an adaptive reuse, putting a container out in the parking lot like you mentioned, Bill? Or are they just going to wholesale throw up their hands and give Equinix a call? What does that landscape look like? And is there an opportunity either for adaptive reuse of existing corporate facilities, headquarters space, there's some vacant real estate, or others like Wade showed on the screen, a shopping mall or something crazy like that? Look into your crystal ball over the next few years and tell us your thoughts.
Maybe there's some edge cases that I can think of where an enterprise customer might have something in their own facility, but it's like the fourth wave of like moving to the data center, moving to the interconnection data center of enterprise workloads, because every time that we look at a use case for a customer, we always find a way of saving them money by putting it into one of our buildings rather than having it on their own site.
You're good at this, yes.
Of course.
But no, it's Matt. I mean, Matt, that it is cheaper to have it outsourced in that case with you guys. We've seen that for decades.
Yeah, that was a lot of questions that you asked again. Like
I'm
my
trying
brain
to- come
doesn't
on,
work
I'm
that
trying
way.
Come on, guys. Work with me.
Yeah, so I think we've been talking about edge for how long? I mean, fuck,
Too long, yes,
ever
forever.
since I've known you.
Right,
We
right.
were talking edge, right? So I do think there's a case for this, though. Going back to the GPUs that are obsolete because they're 3 years old and you're only making 99 cents an hour on those things, and they still have a purpose, and those are going to the inference section or a CPU. A lot of enterprises have built, Taj Mahal data centers, 2 megawatts, woo! But it's at the edge now, so that's something that we can actually do an adaptive reuse and take that facility that was built to a tier 3 or tier 4 back in the day, increase the power loads at those. Hopefully, the white space in data centers. When we were building data centers 15 years ago, it was 90% of the data center was white space. That's where your servers and cabinets go, and then there's 10% gray space. Our data centers today, complete opposite. I mean, my gray space is 90%, my white space is 10. I mean, a room like this can handle almost, 100 megawatts of IT load now? That's unreal.
Yeah, it's a lot more.
Yeah.
I mean, and that's the funny part, was programmatically the data centers change. So let's get back to what Wade showed today, which is a 14 cabinet lineup. That's 5 megawatts, and that does 1,000 times more compute than an equivalent kind of commoditized cloud. So it's just, like a Formula One car and a Hyundai are both cars, but they perform very differently. And so that's the scene we've seen programmatically. And one thing was, like, so working in 4 or 5 bespoke AI builds right now, none of those buildings look alike. Not physically, nothing close. Some look like squares, some look like long sticks, they're stacked. I mean, it's just, that's part of the invention curve everybody's going through. But we all know, we've been in the business long enough, all of us know that you put a bunch of smart people in different rooms, they usually come up with the same answer eventually once they cycle through it. But you bring up a good point when you look at it, and it looks like almost a circle of infrastructure around a very small data hall. Now, the one thing we've seen with the data halls, we've seen them go from 5 to 10 to 20 to 50. Now, 50 is an outlier case, but 20 is kind of the new animal, but that's at least 2 to 2.5 times larger than a cloud hall in a logical node in the old days, just because the compute logical node's different. But the buildings, space is not the problem. If you've got a great building, we can pack infrastructure and into it and power outside, or these guys go build it, and they've got an older building that's a little big. But space is not the problem. It's really power. And to your point was, do you shut the thing down and gut it like Digital's doing in Northern Virginia right now for NVIDIA, or do you have to do what Greg does, which is neurosurgery? It's not even open heart surgery. I think it's neurosurgery. So you're not going to die, but you're going to be crippled if you make a mistake.
Finally, that's all right.
So for new builds, if we're using this rough number of 5 megawatts is the AI deployment unit of the week, at least, does that drive basis of design, what kind of buildings we're looking at, how we do greenfields, do we stop doing greenfields, all of that mix, do you think going forward, is that going to really change and create this big fork in the road for what we've been doing?
Depends how big the building is. I mean, if you've got a 20 megawatt AI load, it's a 20 megawatt cloud load. If you've got a 50 or 100 and the building's not big enough, you have to it just depends on what they want to do with it.
5 megawatts is a great number. I'm glad that they've settled on a number and quoted a number. It helps us plan because, as was mentioned earlier, their cycles are faster than building buildings get built. So it does help us plan that they're going to settle on that number. We can plan in 5 megawatt increments. We've been working on the notion of 5 megawatt probably for about the last year and a half, as thinking about how that gets built and sizing all that plant that goes with it to match that. And we'll just build it up in incremental bricks, and we're aligning our supply chain behind that to be able to execute 5 megawatt increments at multi-hundred megawatt scale.
I think that like we're kind of missing like a bigger point too. Like the AI is not, it's not a very static load inside these data centers. So like we have one of our data halls that goes from 780 kW to 12 megawatts in 90 seconds. And it exceeds the 100% rating on our UPS systems. And that I mean, it just skyrockets. And then your chillers have to keep up with this. And then the chillers are sitting there going like, well, now the load went away, but I can't turn all the way off because that load might come back. So like there's other problems that we're facing. And I think that from a design perspective, we're really trying to focus in on the scalability and flexibility of not what just is happening today, but all of that new technology that we're having to build for 2 years from now, 3 years from now, 5 years from now. So I understand 5 megawatts is great. Like we're getting people asking us for 1.5 gigs. So yeah, so how do like that's a huge data center. That's a $20-30 billion capital investment that we have to come up with. And again, like the reason why we look at adaptive reuse and we looked at the land sites that we actually have, it's they're hardened facilities that have had a lot of power, a lot of water is available. There is network infrastructure in place. It's already pre-permitted for heavy use industrial, which is also inclusive of data centers. Now I need to build not what's just there today, 600,000 square foot shell that sits there. I can put, whatever, let's call it 200 megawatts inside of this building. I need to be able to grow that 200 megawatts to the 1.5 gigs now. So I have to be able to be scalable and flexible and solve solutions that we don't even know what we're solving for. And thank God AI is out there. It can tell us what we need to solve for now. I just have to ask ChatGPT.
So let me hit a couple of programmatic points, and that was a really good one. So when you deal with campuses, right, in the past, 100, 200, 300 megawatts, buildings, substation, done. Now you have to figure you got a power plant parked out there in some way, shape, or form that if you're dealing with air-cooled chillers, every 100 megawatts takes about 20 acres of air-cooled chillers. So the site planning changes. This is kind of just a programmatic change, and I actually was happy to see the dry coolers coming in higher inlet temperatures because that'll take some of that yard space back. If you're in Central Texas, it's not a big deal, but if you're sitting in Northern Virginia or Santa Clara where land is $5 to $11 million an acre, it's kind of a big deal. Well, the other one too is I want to talk about something electrically that we touched on the current transient. Typically, we've seen in the cloud facilities, it's a voltage and frequency transients. That's what you worry about. In the AI plan, it's a current transient. They say it's well published, but no one has ever actually put the current transient curve on the web, but it's out there. And you get it typically when the processor fires, it goes to 180% of load in 20 milliseconds. It comes back down and does that every 2 seconds on the highest clock rate they have. What that does is what's funny is the UPS buffers that, and so you have to watch two things on that. One is the instantaneous rating of the UPS itself. You want to look for a module that's typically above 180% or 175. 200s work best, and you have to have better batteries. The cloud batteries just get chewed up something awful. And so the other thing we're doing topographically within the electrical design. If you've seen some of the designs, kind of the first gen's design, it looks like a cloud design. We've got a UPS plant and we've got one chiller and we've got pumping with it. And we may have continuous cooling. What's happening is we're actually oversizing the UPS. So the cheat code on getting around 2.5 megawatts, and if you can't make the rating of the UPS work, you simply oversize it by one frame size. You go from 1,000 to 1,250, 1,250 to 1,500. That's the cheat code, works fine. We actually did that study for an unnamed hardware company that was just hanging around here talking a few minutes ago, and it works just fine. But you have to be a little creative. You can't just take the playbook from cloud and try to shove it into the AI block. It doesn't work that way. But the UPS sizing, but what happens is we're splitting off the mechanical loads into their own main switchboards, and we're getting kind of back to the old days where you have a critical power system, and then you've got a continuous cooling system in parallel, but they're not on the same MSB, because we're frankly running out of power for the 5 megawatt block.
Thank you, Bill. Let's turn to sustainability. Back to sustainability. We haven't seen so there's been a focus on AI deployment, and AI is anything but sustainable, right? But again, we still have board level goals around sustainability and ESG, quotas and numbers to hit. Does anyone see a carbon accounting credit, so to speak, arising for adaptive reuse, which would increase, its applicability, or would start this kind of rush to reuse buildings, since on the front end you got a big credit in doing so? Sean, with what Tech Fusions is doing, have you heard about this, seen this, legislating for this, and anything going on?
Yeah. So those that know me in this room, I created an ESG software company a few years back. And then I got sick and tired of going to these meetings, and then they said, "That's cute."
But we're not doing it.
We're not doing it. We'll just go buy carbon credits and offsets and RECs, and we have greenwashing, right? So now we have to figure out, if it's so cute, how do we fix this? And going back to the concrete, right? There's sustainable solutions in concrete, so we can drop the embodied emissions of this. But having the capability to come in with a story to talk about, we just saved 80% of embodied emissions by having a facility that's already pre-built, and those are already, written off. So it's not my scope 3 emissions anymore. Now we're getting into what we're doing on the nat gas side. So for the nat gas turbines, we're actually repurposing the steam and heat and creating energy with that. So now our PUEs are becoming closer to a 1.
So absorption chilling, how you guys handle it?
Right, legit. We're not saying that our PUE is 1 and then having a 2 PUE and whatever. So
but you're using dual cycle. You're using the systems for what they're used for.
That's right. So finally, now that we don't have to work on the utility side and get some coal power plant generating the utility power, delivering it to our campus, we're actually creating cleaner energy right off the bat. We're repurposing steam. We're actually giving that back, for what, if you're building, greenhouses for your 420 comment, or you're building, schools that need to be heated, or, hospitals that need to be heated. That's exactly right.
What is old is new again.
Yeah. So now that also has a carbon footprint that we get to capture back in our solution. So there is a big push out there. There's still clients that come to us and say, "Hey, we want to put solar fields, and we want to put turbines that spin around in circles when it's windy out." Now in Pennsylvania, for example, it's not always sunny in Pennsylvania. It might not be the best part to put solar farms there, right? And if it's in a solar farm that is not on our property, this is something we totally forgot to talk about too on the power side. There's a lot of companies out there that can generate power. But so with FERC 2222, and look it up, it's a real thing. You have to, if you're going to use the power for your campus, you have to be the owner of the power that you're generating. So with our nat gas turbines, we're generating that power that we can put right into our own data centers. If you go out there and talk to a different organization, they can generate the power. It has to go through an interconnect. Then you can buy it back from the utility. That could take 5 years. It could take 10 years. So we're basically skipping the process, and this goes. And the reason why I'm talking this is because of PPAs and solar or wind and all these other things. If I'm not the one that's generating that power, and it's another company coming in and generating that power, I have to throw it through an interconnect and buy that back. So that's important when we talk about time to market. We don't have the time to wait 5 years to be able to get that done. I have to have that power online tomorrow.
Do you think that time to revenue variable will become more and more important? Kind of referencing what Bill said about the diff between capital markets and leases, are we going into a new period of this just super compressed return on investment? Will this change leases? Will it drive more adaptive reuse? Any thoughts there?
I think you're going to see a lot of these companies that they sign their 2-year agreement with Microsoft, for example, but they have to sign a 5-year agreement for a colo if they're lucky and someone's actually going to take that offer, for 100 megawatts. So now they have to sign a 15-year lease. I got to go build my own data center now. I can't get an operator to do a contract with me on a lease for 5 years, let alone 10 years, when they're going to spend $2 billion building out this 100 meg, 150 meg delivery for us. So now you're going to see a lot of them, and it's already happening, right? You get some of these neoclouds are already building their own data centers. The reason why they're doing that, one, is time to market. They think they can build it faster because they built a crypto data center that cost them $500,000. And they're like, why is your data center cost so much more than the data centers we built?
Built it in to catch fire.
The cardboard box and the big fan on the outside tell you why my data center costs more. So, like that's what's happening right now, and they're trying to figure out like how, if we can go build a data center faster than all these other operators have been doing this for their entire careers, then let's go try this out. Once they fail, then it's going to be a cycle that comes right back, and it will fail. Like there's just no way that the expertise. I mean, we've been doing this for 30 years now. We have a lot of people that know how to do what they're doing. We're so different than the crypto era. This is something that we've been, studying and focusing on for so long. And what they're going to miss out on is the scalability and flexibility on what you need to build in the future, not what we're building today. Was that saying that like some of our partners?
That was beautiful. I laughed. I cried, Sean. That was beautiful.
So.
Yeah, let's turn back, Greg. Let's turn back to interconnect for a moment here, because one of the big sell points of adaptive reuse is, oh, it's easy. You have land, you have a building, you have some power, you just throw it up, it's going to work. You can build an AI data center. What are your thoughts on, as we transition into inferencing, the thoughts on the value of connectivity, interconnects, big pipes, transit, all the things that Equinix does really, really well? What's your position on the value of that long term with AI technical builds?
I can see a future of, training in more remote locations. I think that makes logical sense. Builds are cheaper, the land is available, potentially even the power is available in some of those locations, or you bring in gas plant to generate it yourself.
If our booked work is any indication, they're all remote sites right now. So, yeah.
But we don't see the interconnection data center dying. We only see it getting stronger as a result of everything that is going on in AI. All of that AI inferencing is going to need to be, once the training is done, it's going to need to be used to generate real money for people. That's the inferencing side of things. As I said before, I think that's going to happen in our retail facilities. It's going to need to be interconnected to clouds. It's going to need to be interconnected to carriers. It's going to need to be interconnected between neo clouds, one to another. They're going to need to share information. So the logical place for it is in the inference data center. I wanted to get one word in on sustainability before, and just to mention heat reuse. We have a number of initiatives going on around heat reuse, and I'd really advocate everybody to think about it, because we just think it's the right thing to do. And it's one of the benefits of having a more urban location compared to the training facilities that are very remote. It can be quite difficult, other than perhaps a greenhouse, to reuse some of that heat. We've got an example in Paris where we've reused heat and dumped it into a district heating scheme that heats the Paris Olympic swimming pool that you probably saw on the TV last year in the summer. We have a case in LA at the moment where we're trying to heat a school board's swimming pool next door to one of our buildings in LA. We're trying to do everything that we can where possible to export heat from our buildings, and we'll go the extra mile to do that.
Do you get community credits, carbon credits, anything to that effect directly from doing heat reuse?
I think the rules are a bit wonky on that. I'm not an expert on carbon accounting, but I don't think we can claim credit for that officially, but it's a great story for us, and it's the right thing to do for community around us, so we're doing it wherever we can.
You just brought up another good thing about adaptive reuse. So when you talk about the local economies, so one of our sites in Pennsylvania, it was a thriving community. There's 10,000 employees. They shut down the factory. The local policyholders are the ones that are pushing even more for us to come in and build massive data centers there. So the tax advantages and tax credits and grants that the local communities are giving us, because I mean the data centers alone are going to create hundreds of millions of dollars in taxes right back to the local community and all the jobs that are created out of it. So adaptive reuse has more than just the embodied emissions of carbon captures and all this other stuff. It's also giving back to to those local communities. Education, I mean, especially like this, right? We got Pittsburgh, and we got some universities that are in that local area. And how many, if you look in this room, I don't see a lot of 20-year-olds, sorry. But like, wouldn't it be awesome to get some younger generation to like take our jobs? I mean, I want to retire tomorrow, so like I hope someone else can replace someone like me. No one's going to be able
Impossible.
to do that here.
Let's go to, we've just got a few minutes left. Let's pause and see if we have some audience questions. We'll take those, and if not, then we'll close out.
And there's
but,
a mic
yeah,
right up here if you guys, because they're recording, so if you guys pop up and
go for it, Bill.
let it rip.
Is this on?
Yep.
This is for bachelor number one. When you're talking about utility, so you guys build the plant. Do you pay for the plant, or does the customer pay for the plant? How does that work?
So let's talk about like Dominion. So the PJM market, actually there's a couple of things I want to talk about this. So like PJM just announced that they have a 10x multiple that come in our way. All right, so that means that if you're paying 7 cents a kilowatt hour, you're going to be paying about 37 cents a kilowatt hour. Be very afraid about this.
California gave you the
Yeah, that's right.
and Hawaii was ahead of it.
Hawaii was done, and all the other ISOs in the U.S. are going to figure this out, and everyone's going to be paying a fortune on their power costs.
Mention your peg to natural gas costs.
Yeah, so my natural gas all-in cost is going to be anywhere from 11 to 13 cents a kilowatt hour for a fixed term for 15 years.
And no demand charge.
And no demand charges. So the reason why I bring that up is because if it's on utility and you need, and Dominion comes to you and says, we got 200 megawatts, you have to start paying us right now, even though you're building your data center, it's going to take you 3 years to build. So now for 3 years, you're paying for 200 megawatt hours. But I don't know how you can sustain a company doing this. So you go to nat gas, right? So all these other companies are going to say goodbye. Nat gas, our generation of power, we are delivering. We have Tech Fusion's power, so we're our own power utility company as well. We don't have to reserve the nat gas utilities, so we're not paying for them. And I hope there's none of them in the room right now, and they figure this out, where they start doing what the utility grid, the electric grid was doing, and start charging a premium to reserve.
Well, if gas demand is going to go down because of fleet electrification and building electrification, which are much bigger loads than data centers themselves, the gas guys want to be part of the demand. They want to be part of the energy story, and this shift between kind of gas demand and electrical demand that we're seeing literally underfoot today. The gas guys are much more willing to play ball. The electrical utilities they're kind of sweating everybody on the client base.
I don't want to lose sight of the long-term answer, and I think the long-term answer continues to be that the US and other countries will need more transmission infrastructure to deliver power from generating stations of whatever type, be they PV, be they coal, be they nuclear, whatever they are. And the short-term answer is some sites will require on-site generation with gas to be able to get over that hurdle. But if we're going to green the grid eventually, we have to have the transmission infrastructure in place to get us there.
Absolutely. Next question.
Great comments. Thank you. So John Medina from Moody's. Question on the power. So what we're hearing mostly is that, honestly, that the gas is taking too long and that behind-the-meter construction is really not being authorized by the utilities and the regulators. So where is this confidence in the behind-the-meter builds? Because what I'm seeing are direct contracts with massive utilities to build the power plants with long-term PPAs. I'm seeing not behind-the-meter. So how do you think that's going to come about?
Do you want to take this one?
Let me start it, because we actually have we have a fairly large site in West Texas that actually has that exact problem. They're waiting for interconnection, and it's a gas plant right now. So I think to be blunt, it gets down to what you're paying cost per kilowatt hour and what your total utility demand is. The challenge is the utilities do not react as fast as the markets will demand. And it's not that they're bad people, it's just that they're utilities, for Christ's sake. You don't want them running with scissors and a lit road flare on the other hand. But that doesn't match the business that we need, and frankly, the scope of the need we have. Now, we're seeing energy providers step into that space and say, I'll give you this asset here, maybe in island mode, but it eventually may be interconnected. But that tactic that's the market's responding to what's going on right now.
Yeah, so we have, in our PA site, it's all wet gas, right? So there's 12 fracking plants that tie into one of our dryer plants. 2 of the fracking plants sit on our premise. I think that's a really good question, and I think that the world has to hear about how this works, because it took us 3 years to get that drying plant established on our campus so we can actually use the gas that we're, the 3 gigawatt campus that we have. All these other companies, this is like crazy because it's all vaporware. It's out there today anyway. I got 25 gigawatts of power available. Do you really? How are you getting all that power? To your point, I think that was great, because if you don't have all the infrastructure in place, that gas means nothing. It can't work and it can't deliver the power that you're asking for.
But your drying plant is no different than if you're building a town, that you have to build a wastewater treatment plant, you have to build a fire station, you have to build infrastructure. When you're putting something like that together, the ride's not free and the developer has to bear that. We just view the power equation as part of that right now.
Next question.
Yes, thank you very much. Really interesting panel. And Dimitri Papakyriakou with Hexagon. My question is, you talked about reuse for retail, but what about first generation, older generation DCs that you want to future fit as opposed to retrofit? What's the approach? What have you seen, including perhaps adding behind the meter solutions to address both power, but as well as, other challenges?
I'm a little hard of hearing, so I think I got that, but maybe if I got it wrong, do apologize. I'd answer that with buildings that were designed for pretty low densities in the past are being redesigned and kitted out for much higher densities to accommodate just incremental increase in customer workloads. Customers that maybe used to have a 100 kVA cage that had 50 cabinets in it, they still exist, but that equipment is being cycled, replaced over time, and being replaced with equipment that's 10 kilowatts a cabinet. So our buildings have to be able to accommodate that. So we're constantly upgrading our fleet to be able to accommodate that kind of change in what customers demand in existing buildings. Did that approach an answer to the question?
And by the way, there's always a last mile change and, more power to the cabinet, change the network. That's just, when you do a technology refresh every 3 to 5 years, that's part of doing business. To Greg's point it's the mass tonnage of cooling or the mass megawatts in the building for total power or UPS power. That's where the harder retrofits become.
We're over. We'll do one more, and then if there's any other questions, you can grab us right after.
Yeah.
My name's Charlie Westbrook with Resource Environmental Solutions, and I was wondering, in all this build-out, the demand is there, but the supply of keeping up with all the build-out and such, are there any innovations in environmental permitting that's going to allow the physical matter to get to market to be able to reach demand for services?
Environmental permitting versus operating permitting, or?
Yeah, in terms of, we like in Greenfield, you talked about adaptive versus Greenfield. Is there anything, innovations or speed to market considerations that the permitters are allowing?
No, but let me start with no, but let me also say that I've been building buildings for 42 years, and every approval process is prescriptive.
Right.
If you follow the process and actually, I wouldn't say aggressively manage it because you really can't push them, but you kind of keep things moving, things get approved. The guys that die on the vine are the folks that kind of throw it over the wall and hope it gets done, and or don't, by the way, also treat the jurisdictions like they treat them poorly. You have to kind of partner with them, and so you have to manage through that. Anybody that does real estate development, that's part of the shtick.
I'll take a crack at that and say that there are locations that will sell themselves short, and these kinds of buildings are mobile to some degree. There is a site selection process, and we will select locations that make it easier to build. Those locations that are harder, we're going to avoid.
Yeah, I would agree with what they said. And I think that if you look at what we're doing with diesel, diesel power generators versus nat gas turbines, the cleanliness of this with EPA, I mean, it's by far more clean. So when they learn what we're doing and the type of emissions that are based on what we're doing, it becomes a lot easier to grease the skids on there. I come from Chicago. I shouldn't say grease the skids, but
What
we're
about
not paying them off.
What about specifically like environmental, like
Enabling the process.
wetland and stream credits to offset environmental impacts from development?
Thank you.
All right, folks, thanks so much for your interest today. Let's give a hand to our panel.